Well, good afternoon, everybody, and welcome to the Thursday, November 2020 session in our series on traditional and new industries undergoing digital transformation in Asia. So today we're going to talk about how digital transformation is being enabled. And I'm delighted that our speaker is Mr. Brian Burns, who is the Vice President of Asia Pacific for Cloudian Incorporated. And Brian will tell us more about Cloudian. He's joining us from Tokyo this afternoon. He's been in this position for a couple of years now. He is also an adjunct professor of data analytics for the New York University School of Professional Studies. He has been working in Japan for a number of years for one American tech company after another. He's got his undergraduate degree and his MBA from UC Berkeley. Undergraduate, he studied both engineering and Asian studies, so he's also a speaker of Japanese and Mandarin Chinese. So I'm really delighted you could find the time to share some perspectives with us today, Brian.
The
Uh,
transformation. Yeah.
Let me turn the microphone over to you, but before I do, note for everybody, please send us your questions on chat, and I will put the questions down and relay them to Brian. And if you have any more time after the end of our formal session, which is 5:40 in the afternoon, we will have an informal, very free kind of discussion from 5:50 until about 6:15 or 6:20. So thanks very much for coming, everybody. Brian, the floor is yours.
Well, thank you very much. I'm honored to be able to speak to you folks. And can I start by making sure people can see the agenda? There's a lot I plan to cover today, and in the consideration of time, I will start right away. Again, my name is Brian Burns, and thanks everyone for joining. I work for a company called Cloudian, and I guess in a nutshell, what I do, I sell North American technology to companies in Asia. I've been doing that for virtually, it seems like my entire life, certainly for virtually my entire career. And actually that career did start when I was like many of you students. When I was a student undergrad at Berkeley, I was studying both Japanese and engineering, and went to work to Japan, went to work in Japan in industry, graduated, and started going back and forth to Japan and other places in Asia for different American companies. And a little of the backdrop of that time, and any of you who've studied contemporary Japanese history will know that the 80s for Japan was really the golden age for them. They were on fire. They were basically dominating so many industries. They were, people were seeing them as a country that was going to take over all aspects of technology. There was something else that was on fire at the time, which was the relationship with the United States. Their rise and economic growth was making a lot of folks, especially a lot of politicians, rather uncomfortable. There's the famous scene of a congressman on the steps of Capitol Hill, taking a sledgehammer to a Japanese, I think it was Toshiba tape deck or something, and smashing it. And that's kind of what was going on when I started going back and forth to Japan. In Japan, I was working as a robotics or an automation engineer. And what we do is basically take different things and put them together. And what I was doing is actually sourcing a lot of American technology, mostly software. And from my perspective, I was seeing something different than what I had been hearing, which was that I really felt that American software technology had a significant advantage against Japan at the time. But the technology and the software I was purchasing was typically, 3, 4, 5 times the price that I might pay in America. It wasn't really supported very well. And I really kind of thought that there was something wrong with that. And I really thought that maybe I'd like to right that wrong, and knowing that it would be very difficult as an engineer to do that, I decided to go back to school, went back to business school, and I've been doing exactly that since that day. So that's kind of the background on me and how I got to where I am. Now, today we're going to talk about the cloud in Japan. And throughout my career, as you see lots of new technologies coming into the marketplace. Some of them come, some of them go, some of them stick, some of them don't. You've probably read Jeffrey Moore's book on crossing the chasm. Many of the technologies don't cross the chasm, and I've worked with both technologies that have and haven't crossed that chasm, and typically bringing them to Asia. Over the last 5 to 10 years, I've been focusing a lot on cloud and big data and those type of technology, and that's what I'm going to focus on today. I do have a section that I was going to start with about why Japan in the context of Asia. Why should we focus on Japan? And kind of the factors and the things that I look at when I decide which Asian geography to enter first. Because it's in this consideration of time, what I'd like to do is skip that. And if anyone's interested, we will have time for Q&A at the end, and we can go through that if you like. So what I'm going to start with is a quick discussion about the cloud and why people are using the cloud, what they're doing with the cloud. And it's not necessarily because that's what we're here to talk about today, but because by understanding this, it really gives you a very good perspective and understanding about the very specific and unique challenges that Japan has had in cloud adoption. Okay, so I can start by asking the question, what is the cloud? And I'm sure if you ask 10 different people, even in the industry, you'll probably get 10 different different answers to this. I even got a very interesting meme recently explaining that there is no cloud, it's just someone else's computer. Now, I would say that this is not only completely misleading. For one thing, it's not really telling, it's only telling a tiny bit of this tiny slice of the story. It's almost like saying a book is nothing more than ink and paper. But in fact, it's actually patently false. And I'm going to talk a little bit about why it's misleading, and later on go into why I believe it's patently false. Now, if you were to ask me to create a meme, I might say something like this. The cloud is a highly virtualized shared pool of compute and storage resources and their dependent services accessed through an API. Now, I can assure you if I published this meme, it would get many fewer views than the meme on the left, but I'm confident that it's probably a much better characterization of what the cloud that we know of today is. So one way to think about it is look at it from an infrastructure perspective, the actual hardware, and what hardware looks like. So let's take a look at the hardware before the cloud. So this is what a large enterprise hardware infrastructure might look like before the cloud. Now, if you were to look at after the cloud, it looks something like this. Now, you might notice some similarities. Well, in fact, they're actually identical photos, because from a hardware perspective, from an infrastructure perspective, there fundamentally is no difference. It is all something else. In my characterization of what the cloud is, there's a couple of, I think, very key operative words there: virtualization and API. And so what do we mean by virtualization? Now, if we look at the traditional, way of running an operation, of creating and running an application, you have applications that are running on a specific operating system, and they're dependent on that operating system. And that operating system is working on top of a hardware, a specific piece of hardware. And of course, it's dependent on that. And there's dependencies up and down this stack. In short, this application will only run on this version of operating system on this hardware and nothing else. Okay, and that's the way that applications have been deployed, developed and deployed throughout the years. So what virtualization does in very simple, and I'm going to give this in just a very conceptual term, is they're basically taking the operating system and hardware and basically virtualizing that to the point where you don't even really care what operating system or what hardware it is, because that operating system and hardware, firstly, will exist in some cloud somewhere. Okay. Now, how, and the next, so that basic computing stack will basically just become your applications. And those applications will communicate with that cloud of resources through something called an API. And the API is fundamentally different in the following way. If in the basic computing stack, the application was basically telling the operating system and hardware how to do something, the API basically allows you to instead of telling the cloud or telling these resources how to do something, it's basically telling them what to do. And for that reason, the API is often referred to as a butler. And it's the difference between making your own dinner and just telling the butler to make me this dinner. Okay. Again, this is very highly conceptualized, but it gives you an idea. Now, if we dig a little deeper and compare traditional versus modern ways of creating applications and deploy them, applications were traditionally created something called the waterfall development, which is a multi-step process, and they're creating something called these applications which are monolithic. And you can imagine these large organizations with one big monolithic application. I've met companies that have applications which are tens of millions of lines of code, which might have been created over decades by people who no longer work at the company. And these are applications which take literally many, many man years to create. Okay. And if you can think of, for example, a good analogy would be Facebook. I think all of you have used Facebook. You know that it's an application that does many, many different things. Okay, and if you can imagine that as one big monolithic application, it would be something that's doing a lot of things at the same time. So this was all, you can imagine, as I mentioned earlier about everything's dependent on the operating systems and the hardware. You can imagine upgrading that could take months and years in some cases. Very human resources and cost intensive. But fundamentally, you have a situation where it's created and developed by the developers and is deployed by the operators, the people who actually manage the infrastructure. And one problem, a key problem, that these people are quite different beasts in the universe of application development. They're like Venus and Mars. They typically don't like each other and they don't work very well together. And so this is kind of what most companies have been dealing with for all time. Okay. Now enter a modern application development and deployment cycle, often referred to as DevOps. You might have heard this term before. So DevOps, everything is quite different at a very fundamental level. Instead of creating this large monolithic application, you're basically breaking it down into small microservices, small elements that are typically doing just one very, very small part of the entire job. For example, if you use the Facebook analogy, for example, making a post would be one microservice. In reality, doing that post may be many different microservices, but for simplicity, let's think of doing that post being one microservice. That microservice might be containerized. And if one way of thinking that is putting this microservice in a little container, and you can take that little container and basically send it anywhere. And as long as there's a virtualized infrastructure in a cloud somewhere, you can basically throw it there, tell it to stand up, and it will work. I like to think about these little pods of workers as worker bees, okay? And if you think of, take again the Facebook analogy, these worker bees will go out and they'll be there wherever, maybe they'll be close to where a lot of customers or a lot of users are who are posting, and they will sit there and work and do those postings that the Facebook users would like. Now, if you need more, because more people would be posting, you basically just send out more worker bees. You can send out almost an infinite number of worker bees to do that. The reason you wouldn't do that, or you wouldn't send out a lot more than you need, is because typically, especially when you're using a public cloud, for every worker bee you send out, you may be paying that public cloud that much more money, okay? And that's one of the basis of this pay-as-you-go, is one of the basis for the public cloud and how you work with folks like AWS. Okay, so taking the Facebook example, for example, like say, let's take a hypothetical example of say there's a presidential election, and say one of the candidates were to say, you know, flip a couple of states, like hypothetically Wisconsin and Michigan. All of a sudden, many users may want to express their emotions in a post. And if Facebook were to anticipate that, they could very quickly deploy. In fact, I work for a company called HashiCorp, which could deploy 1 million of these worker bees in under a minute. They could deploy those anywhere in the world to meet the demand of those, you know, people expressing their emotions through a post. And when they felt that they didn't need it anymore, they could basically just flush them out, okay, eject them, because they want to, of course, they want to make sure that all customers who want to do something can do that. They're not turning away any requests. But they also, because they're a business, they want to minimize and optimize their cost. And so they want to flush those out when they don't need. And this is one of the ways this all works. You can imagine that all of this would require a lot of orchestration. And that's what a tool called Kubernetes, which you may have heard of, does. And so this is in the same way that you can bring these in and take them out when you need them and when you don't need them. If you, for example, have an idea to create a worker bee that does a similar or the same job, that's better, faster, cheaper, lighter, whatever, instead of basically bringing your system down, flushing out the old ones, repopulating it with new worker bees and starting again, it's quite different. You basically, you can take a few of these new worker bees and just start gradually throwing them out and seeing how they do. And if they do well, over time, you flush your old ones out and repopulate them with new ones, okay? And this is referred to as continuous development, continuous integration. Now, for any of you who might be pre-med students or have a background in biology, if this sounds a lot like the way the human body creates blood cells and flushes itself of older blood cells that are no longer useful to it, there's no coincidence, because a lot of this was modeled on that. Okay, so this whole idea of this elastic infrastructure scalability, complete virtualized infrastructure, pay as you go, and very importantly, a much shorter time to deployment. This is all very core to digital transformation and very core to cloud, because this is how people are using cloud to get the most out of cloud. By adopting DevOps, you can basically make it all happen with these highly virtualized environments called clouds. So it could be that some of you may have very little interest in this specifically, but you may, I'm fond of telling a certain anecdote, and if there's anything you might remember from this, it's the story that I often tell about Uber and Airbnb. Any students out there, I'm sure you're very familiar with Uber and Airbnb. My son, who's also a student with no visible means of income, but he has an almost bottomless capacity to consume these services. I'm sure you're all aware of these. You may be less aware of the story behind them. When they were fledgling startups 12, 15 years ago, it wasn't a situation where Uber had invented drive sharing or ride sharing, and Airbnb had invented home sharing. The concepts were out there, and there were many companies, all of which were trying to do the same thing. Most VCs had investments in different companies, but as you all know, these are the two companies who in the end succeeded. Now, if you look a little bit closer about why these two companies succeeded, it's very clear that both Uber and Airbnb simply executed on the idea much earlier and much better than their competitors. Okay, they were able to bring a critical mass of new users onto their platform earlier than others were, and the rest is history. Okay, but it is no coincidence that both Uber and Airbnb were some of the earliest and most aggressive adopters of DevOps technology. And by doing so, they proved to virtually all industries that no industry is protected from the potential attack that's coming out of a garage from a few people who have an idea and understand how to deploy technology really well. Okay, and so the message that they sent to the industry basically showed the rest of the world that this is the way things should be done, and that's kind of what is happening. Now, how does this all figure into Japan? I can start by saying that Japan has always had some very unique structural impediments to almost all IT adoption. Okay, many reasons there, some structural, some cultural. One of them, clearly structural, is something called the keiretsu. And for those of you who studied Japanese or are aware of the keiretsu, you know that they're basically these corporations. You may have heard of Mitsubishi, Sumitomo, Hitachi. These are all keiretsu. It's not one single company, but it could be hundreds of thousands, in some cases, 10,000 plus companies that create this keiretsu. And within the companies, for example, Toyota, we know Toyota as a company that make cars, but they're surrounded by companies with which they have cross shareholding and that provide them parts and provide them many things. But one of each keiretsu will always have at least one or many system integrators. And these are the companies that provide IT technology to these large Japanese traditional enterprises. Okay, so companies within, they're kind of expected to deploy the services or to use the services, outsource their IT to these companies. And one of the effects is how Japan's pool of IT is distributed within the country. Okay, I call it the 80-20 rule, and maybe closer to 70-30 rule. And one way is to say, for example, look at American IT. If you are doing banking, IT for the banking industry, you're probably working for a bank. If you're doing IT for autonomous driving, you're probably working for an automotive manufacturer or someone who just does that. In Japan, and so about 80% of all the IT talent is working in the industry. In the specific industry, and about 20% might be, or 30% might be working for example, a system integrator or consultant. In Japan, it's the opposite, where you have over 70% of all IT professionals are working for system integrators. And that creates some very interesting and basically some impediments to adoption. One of them is, from the top down, CIO. Up until 10 years ago, there virtually were no CIOs in Japan. And, 5, 6, 7 years ago, when you started seeing them appear mostly by board of directors, forcing companies to bring on CIOs, very often those CIOs would be transferred from, for example, the HR department to become the CIO. And that's one of the problems you have when, for all time, literally 100 years, you've been outsourcing your IT talent to another company. Another issue is you think of technology adoption as something that is fundamentally making something cheaper or lower cost to do the same thing or do something better. From this perspective, the system integrator, lower cost basically equals lower revenues, and they look at this fundamentally different. And so certainly in the early days of the cloud, many of these system integrators were quite reluctant to adopt this talent. So everything I've been talking about in this page up until now is basically it's based on traditional Japanese enterprises but the fact is that about 25 years ago, with the onset of the internet, you saw some very interesting and very positive changes coming into the Japanese economy. Up until then, the successful companies were basically large Japanese companies in these large keiretsus, and that's how you succeeded. About 25 years ago, internet came. You saw the emergence of companies that virtually coming out of nowhere. Rakuten, which is the Amazon of Japan. You have companies like Recruit, which were more traditional Japanese companies. And Recruit is a really interesting example because they're a company that were publishing books that they would sell to graduating students to help them find the right job. And they looked at the internet as basically their future. And so they made a strategic pivot to the internet at a very critical time. Now, fast forward 25 years, Recruit, or 20 or 25 years, Recruit is now not only the most successful, company helping graduates find their new jobs. They're also the Yelp of Japan. They're also the Zillow of Japan. Their revenues are at least one order of magnitude greater than they were 25 years ago. So these are great success stories of companies who basically looked and realized that there's nothing the system integrators could do for them, because they probably already knew more about the internet than the system integrators did. And they decided, looking at the way this is done globally, they started hiring their own talent and creating that new 70-30 rule internally, and basically taking charge of their own digital transformation future. And one of the results is great success with a backdrop of one of the longest sustained recessions in modern history, which is Japan. And they're basically demonstrating to all industries that there is a better way to do it. And this has been a very positive kind of a breath of fresh air into the industry. But of course, traditional industries have been doing things a certain way for nearly 100 years. These changes will be gradual. So if I look at how Japan has done throughout in adoption of the cloud, and we all know that the cloud has been kind of mainstream globally for the last maybe 10 years. We like to look at this in several different phases. And the first being the simple migration to the hyperscaler. And for the hyperscaler are those public clouds, those large public clouds like AWS, Azure, and GCP. And if we look at how Japan did with that early migration that started about 10 years ago, the fact is, in a word, they were quite late to the game. Okay, and there's lots of reasons why. I think if you think about my last couple of slides, and which describe these systematic issues you have, that you can see the difficulties that traditional Japanese companies might have in making that. But it's actually It's actually much deeper than that. It's much more serious than that. Part of the cloud, or a very core element of the cloud, is DevOps. And so you can imagine that companies that are outsourcing things like dev and ops to other companies will have difficulties doing that. But in Japan, it's even much more serious, and that dev and ops will be outsourced typically to different companies. And if DevOps is all about bringing dev and ops together to do things much more efficiently and effectively, that you can imagine just how difficult and the challenges that would provide. Also, a lot of their applications were using legacy code like COBOL, very difficult to port to the cloud. And the result was basically that virtually all traditional enterprises were quite late, or fundamentally did not make that migration out to the cloud. And that did vary a lot through from industry to industry. And in fact, there's a very interesting report that came out recently, which looked at some of the lions and laggards. And without going into detail, blue here is very good. Blue indicates companies, the number of companies in that industry that have completely transformed themselves digitally. And one of the outliers is the lion would be the architecture and civil engineer who've been doing this, who've been digitizing for decades. The industry, basically the poster child for laggards in cloud adoption has been the financial industry. Okay, what this graph says is there are virtually 0 banks in the entire country that have made a transformation. A lot of reasons there. One of them is cultural. There's this famous Japanese saying, "Ishibashi o tataite wataru," which means you tap the bridge before crossing. Basically, you tap the bridge to see, is this bridge sound, before making the crossing the bridge. And of course, in the technology adoption sense, is making sure that this technology is solid before you actually make an investment into it. And so this has been, two very obvious, or one very obvious effect of this is that technology adoption will be delayed. Okay, and it's traditionally has been delayed by a year, 2 years, 3 years, in some case longer. But there's actually a very interesting and almost a positive byproduct of this, which is something that I call next best thing skipping. I referred earlier to technologies that don't cross the chasm, technologies that for whatever reason, maybe something better came along, or they never really met expectations. They never really crossed that chasm. In some cases in Japan, as they're still tapping that bridge, and something newer comes along, something better comes along, or they come to the same conclusion at the same time that the rest of the world who's actually made that investment, they're coming to this conclusion that, hey, maybe this isn't the best thing. And so in many cases, they have avoided investing in technologies which were ultimately never meant to be. And this kind of leads me into the second evolutionary phase, which is the emergence of the private cloud and hybrid cloud. So if you can imagine for a moment that the type of technologies that I was talking about, the virtualization and these very powerful APIs, they were pretty much only available from these very big, powerful companies like AWS and Azure, say 10 years ago. But over the years, those technologies became much more widely available to a much broader audience. And in fact, most of the benefits and most of the things that you could do in the public cloud, by 5 years ago, you could do in your own data center, okay? Or you could do the same thing using your private cloud in concert with a public cloud, which is often referred to as the hybrid cloud. Okay, so why would anyone want to do that? It's a very good question. We have these great, powerful public clouds like AWS. Why would you want to do that? And I'll also comment that this is the reason why the comment about not just someone else's computer is patently false. because a private cloud is not someone else's computer. It is your computer. Okay, so why would people want to basically start using someone else's computer and then go back and use their own computer? And this was a question that was answered, I think, very well by a report that came out by IDC late last year, where they asked the CIOs and other decision makers in 2,200 companies around the world a couple of very interesting questions. The first one was, in the last year, is there anything that you had been working with in a public cloud, whether it's something storing something or doing a process, which you have brought back into your own data center, into your own private cloud? And the answer was that 85% of all companies reported that they had brought back workload. Okay, and they gave a number of reasons. One was security. They believed that public clouds weren't as secure as they may have thought. It was probably costing them a lot more than they thought. Performance, it's actually happening in someone else's data center. Data has to go across public networks to get there. And so performance may be impacted. But the second question was even more telling. And they asked this group of people, of what you're currently doing in a public cloud, what percentage of that would you be bringing back into your own data center in the next 2 years? And very surprisingly, about 49%, or half of everything they're currently doing, they plan to bring back, mostly for the reasons that I just described. Okay, there's a couple of very high-profile examples of this. One of the extreme examples is Apple Computer, who in 2017 paid AWS almost $800 million. They thought that this was too much, and so they made a decision to just repatriate or bring back their data. And when doing that, if you know anything about the cloud, you know that you have to pay these clouds cost to bring back your data. It paid them, I think, $30 million plus, but actually that was a very good investment because the next year they paid them only $370 million. So this is a very interesting example. Another even more interesting example is NASA. NASA did a 3-year contract with AWS for $65 million a year to basically put all their workload on there and store their data on there. But they left out one charge, which was the egress charge, and that's the access, basic accessing data. On services like AWS, you can take a gigabyte of data and store it there for about 2 cents a month, which looks kind of cheap. But if you want to access that data, it costs about 3 or 4 times that much, okay? And this is a line item, that access charge, that egress charge, that NASA forgot to budget for. And that charge alone was, in addition to the $65 million budgeted, was $30 million a year. So their budget was exploded by 50%, nearly 50% for one line item, okay? So how did Japan do in phase 2? In fact, Japan did, in my perspective, a lot better than they did in phase 1. They were actually a late adopter of public cloud, but they were an early adopter of private cloud. Because when they started to look closely, as they're tapping those bridges, they can see that, you know, by the time it's time for them to make some decisions, they have a choice. They can adopt public cloud, they can adopt private cloud, they can adopt a hybrid cloud, okay? Also, when it comes to truly understanding the costs of what, say, for example, a public cloud is going to cost, you know, when it comes to tapping that bridge in Japan, they pretty much bring out.
Stream. Can we see?
Hello? Okay, sorry. Someone may be on, needs to go on mute. But when it comes to understanding those costs, they bring out the sledgehammer and they truly understand the cost. One way of thinking about this is that, I like to think about this, is that thinking about JAXA, which is Japan's version of NASA. And that, you know, I'd be willing to go out on a ledge and predict that JAXA would not make the same mistake that NASA did. So the third phase, very
They
interesting
go out
phase.
on a limb. We got limbs and ledges and chasms.
Exactly. Lots of limbs, ledges, and chasms. So now we're here in the third evolutionary phase, what I call the edge. Very interesting. Those of you who studied the history of computing will know that, say, 50 years ago, it was all about the mainframe, which is a centralized model. And then that moved to the client server in the 80s, which is more of a distributed model. And then with the mobile cloud, it went back to a centralized model. And now and each of these migrations, each of these transformations is happening for completely different reasons. And yet now for a completely different reason, it's going to the edge. And that is a distributed model. Okay. Now let's talk a little bit about what the edge is and why people are moving to the edge. If you look at the old way, basically you have these large computers with dependent operating systems, dependent applications, and the data that you have is traditionally very transactional data. It's very small, very portable. And of course, you're going to be sending that data to the compute for processing. But today, that's all very different. The type of data that people want to look at is to find those insights that they need to look at to make decisions and how to do things better or differently, are very often large unstructured data like video, like audio, like Word documents and things like that. So you have much larger data sets. And at the same time, your compute is completely portable. Okay, as we discussed earlier, you can basically throw your compute anywhere and it will operate. Okay, so the new way is to basically throw your compute to the data. Okay, so data, the whole issue of data here is very important to what is happening. We saw a growth in data over the last 5 years, which has been phenomenal. It went from, say, 2 zettabytes of growth, and a zettabyte is 1 billion terabytes. This year is probably 42 zettabytes of new data which was added. And in 5 years, they predict it's going to be 4 times that much, 175 zettabytes. That's a huge amount of data. And the fundamental problem is it's just so easy to create data today. But another real problem is that the public network to support that data, if you're going to be sending that data around, you can't, it's not as easy to build out that data. And that purple line you see is actually how the public data or public network is growing. And it's not keeping up with the growth in data. And that is another reason why it will make an increasingly more sense to keep the data where it's collected. Okay. And so Japan in phase 3, we see something very interesting. You see that they're not only aggressively adopting, but they're actually some of the truly cutting edge use cases in edge computing are coming not out of America and not out of Europe, but out of Japan. And we see some really interesting examples of that. So the last thing I'm going to do is talk about some of these really interesting examples. Now, this is an example of a Japanese semiconductor manufacturer, next generation semiconductor manufacturer. This company actually does a lot of things. They also make consumer electronics. They also make movies. You know the company I'm talking about, I just can't mention their name. So if you look at what they're doing here, there's many different manufacturing sites around Japan and around the world. And they're basically, these manufacturing lines are creating lots of data, all kinds of production data, and there might be image data, there might be video data, there might be audio data. You may or may not know that, when we think our car sounds bad because our car might have a problem because it sounds different, there are a lot of high high sample rate microphones in manufacturing that are actually doing the same thing, seeing how things are sounding. And that is, they have robots that actually go in there and look at, is there a problem here? Does it need more oil? Or worse yet, is there a potential for a catastrophic failure that I need to be aware of? Okay, so everything I've described, and so that data is basically coming into a server. And everything I've described up to now is not unique. They've been pretty much doing this for many years now. But what is unique about the fact is that each location, there will be one or multiple servers that are gathering this data. And all of these servers are connected in a network. And they all basically can provide data to one another, and they can all be seen as one cohesive, one unified set of data. And they can be accessed through things like URLs. Okay. Now, if this sounds a lot like the internet, it is because it is. It basically is used and interfaced with exactly like the internet. If any of you who've used something like AWS, where data can be stored or resources can be anywhere in the world, all you do is basically send an API call and it will do what you ask it to do. It will request that data wherever that data might be. It is because that is exactly what this is. It's using something called S3, which is Amazon's default standard for doing that, which is a simple storage system, which is the way that thousands of applications interact in the world. The difference is that this is one private cloud network. Okay, it is not AWS. It is not the open network, internet. And so on the right, you have, say, a analyst, and that analyst might be in Toku, it might be in Mozambique, but basically all the data that has been gathered is completely accessible from them. And because this is an open standard, they're using openly available or readily available open standard or open sourced tools like Postgres SQL and Presto to do all of their analytics. Another thing that is very unique about this is that, I mentioned earlier, the edge devices would like to keep large data locally as much as possible without having to send it over the public network. And so what will happen is, for example, that audio file that's coming in, you need to analyze that. At the server, you have smarts. You have these deployed worker bees that can actually go in there and, using things like artificial intelligence, go in and find out and try to understand what it is about this audio file, what it is about this video file that is relevant for me, so I can make an actionable or an insight that I can take action to, again, increase the yield of this manufacturing unit. For manufacturers, yield is the most important KPI. Manufacturers basically live and die based on yield. Okay, and so that is something that will be happening here, was that all of that data that is pulled out of these large unstructured files will be stored as metadata. And that metadata will be migrated very smoothly. It's very small over the network to something like Elasticsearch, which will allow this analyst to do very quick and very real-time analytics on ways to make this even better. And so this is we've never seen something like this anywhere else in the world other than Japan. Another example, which we found to be very interesting and coming out of a source that you wouldn't really expect this kind of cutting edge example to come out of, which is the Japanese government. So this division of the Japanese government is all about agriculture. And what they're doing is they're gathering as many information sources from as many places as possible, and to ultimately help Japan increase its yield in agriculture. Okay, And so they bring in all kinds of, you can imagine all the meteorological data, like climate and weather and things like this, soil data, GPS data. They send, for example, drones all over Japan to find out all kinds of information, including videos. And some of the byproducts of this might be that they might detect a fire where it couldn't be detected otherwise, or the potential for a flood and things like this. But one of the things that they do at a base level is create a public repository with all kinds of information and that they provide to any farmer in Japan, to allow that farmer to make decisions that may increase their yield of their crop or the quality of their crop. And that is good for the farmers, and that is very good for Japan. What they're also doing is taking this incredibly, we're talking many petabytes of data, and feeding it into this artificial intelligence engine, this inference engine, as training data, to use machine learning to try to understand the correlations between everything they see. They might look at, for example, the head of the rice plant, and see how it is drooping, because that says a lot about the rice plant and how that might be impacted by all of the things that are happening in that season in Japan. And so ultimately, they're trying to understand better how they can make for a better product or better yield for all of Japan. Okay, so these are some really interesting applications that we've seen. I am going to turn over to questions at this point.
Brian, thank you very much. Those are great comments. Can I ask a follow-up question on this last example?
Sure.
You've created this public repository of information for farmers, but how do farmers have the IT skills to be able to do the queries?
It's a very good question. Very good question. And of course, they're taking into account the fact that farmers are not, among in the entire demographics, maybe not the most have the highest IT skill level. But they're creating GUIs that are presenting the most important things to them in the easiest ways possible. So there's a lot of thought going into that. Some of it is delivered in the form of reports, so they don't really need to interact. All they need to do is read. So yes, that's something that they take very seriously.
Okay, and kind of keep going on this line. When the government developed this and worked with some private companies to help develop it, did they use a new kind of DevOps approach to doing the development, or was it kind of old style where it was all ready made and then you train the farmers?
No, they okay. So the concept, what they wanted to do, was something that they've always been trying to do, is help farmers understand and make better decisions. They just weren't doing it very well. It wasn't anywhere nearly as effective. But knowing what they could do with machine learning and artificial intelligence, what was possible. And also from an IoT perspective, the incredible growth in ability to gather data happening at the same time. A number of years ago, they started planning the system, which was going to be fundamentally different. And they did adopt a much more modern DevOps workflow, because they realized that if they didn't do that, they couldn't do all of these other things that they wanted to do. So yes, it was, as you can imagine, it was a big change for them. And a lot of this is happening internally, right? They're doing this, they're not, turning to their traditional system integrators to do everything for them. They've brought in a lot of, or fostered a lot of internal talent to make this happen.
Okay, thanks. Kind of moving backward, we have a question about, I think this is really more the manufacturing company example. So all of these devices have big data that, you know, when you put it all together, that's big data.
Yep.
So are they storing the data in the S3 cloud, or is it, you know, do they keep a backup in the S3 cloud? When you say that it's a private cloud network, that's interesting. How do they do the analytics to take advantage of the scale?
It's a very, very good question. And let me start by saying, I may have missed this very important point, which is that one of the real benefits of doing things this way, if you look, and it's in comparison to, so it's when you compare to how things were done in the past. And so you might, each of these things that are going on here would be a unique use case, which would have its unique, you know, pool of compute and storage. Okay. And one problem with that is that there's lots of inefficiencies, right? You'd have a lot of unused stores and a lot of unused compute. And also data sharing would become much more difficult. What you have here is something called a data lake, where all of this data in this highly distributed environment is available to anyone with the right access. Okay, so getting back to the question, which is, where is the compute happening? It's a very good question. And the fact is that it's happening all over the place. And that gets to the core of the whole idea of edge. Now, in a simpler case, which is just a highly networked or highly distributed, pool of storage, the storage is basically protecting itself. In other words, replicating itself within the entire cluster. And that's one of the things that Smart Storage does. Actually, that's what my company, Cloudian, does. We allow you to create these highly distributed environments of storage that through replication, for example, if one of these servers were to go down, or a tsunami were to hit one of them, that data would have been replicated in at least 2 other places, okay, and can be, you know, reconfigured very easily. And so that's how the data is protected. But getting to the question of where the compute happens, that is the real interesting question here, I believe. And the answer to that is it depends. And so if, for example, as I mentioned earlier, you have very heavy data that you don't want to move across the internet, you would want to do the compute there at the edge. And these computing devices, where they used to be just dumb storage devices where you store your bits, are now much more powerful. And you can run things like Spark. You can run things like TensorFlow. You can run things like ML library or other applications, or some of these AI applications that can actually take a video and go in and understand what's in the video and what relevant information is in that video and create that metadata. And so what ultimately is sent over the internet to, for example, this analyst on the right, is just the metadata. And it allows them to sift through that and see if they can develop any of these insights that they can take action upon. Okay. I hope that answers the question, but the answer to the compute is it really depends. So you have compute happening on the left, and it's basically an issue of partitioning. Where does it make sense to do the compute on the edge? And where does it make sense to do the compute, say, on the right, where you have probably more compute power to do a lot of the analytics, a lot of the hardcore analytics? And so this is the way a lot of people are approaching this. This is an S3 data lake. This is something similar to this might be possible through a technology called Hadoop, which is something I was very involved in many years ago. I worked for a company called Hortonworks, which invented Hadoop. It would just be much more complex and much more expensive to do. What we're working with here, what we have here, is an example of a company that has embraced fully the open source technologies that, for example, the REST API, that everyone has access to and everyone knows how to use, the URL, for example, to do very, very powerful things.
So, you've talked about this from the standpoint of the architecture of the IT and where the compute is and so forth, but you could also look at this in the kind of language that they use in industry, right? That with the machines and so forth, you have operational technology. And what the analyst is doing is really more on the information technology. So this kind of integration of OT and IT in order to have even better understanding of how your whole system works.
Yeah, yes, exactly. And as you say, what is happening on the left is quite different than what is happening on the right. And the goal is all the same, you know, to just increase the yield, to predict failure, to just make things work better. And you know, in this day and age, the way that this is partitioned, and is from what we can see, the most effective and efficient way to do this. And it's really interesting to see that a Japanese company is one of the first in the world to adopt this very next generation way of adopting
So
technology.
why do you think the Japanese have been so early adopters of edge? I mean, in some ways, when you were talking about the sort of three phases of cloud computing in Japan, yeah, okay, not only was the first phase with public cloud a shared resource, but most of the providers were not Japanese. Whereas in the second phase, when you're moving to private cloud, a lot of the kind of sales and of IT, kind of hardware was at the center. And so if you're buying your own private data center and the private cloud comes along with it, it's almost feels different than what you would get otherwise. Plus, it's something that you don't necessarily feel like you're sharing with other people. You don't have worry about security and so forth. So I'm kind of curious how that sort of shift in comfort level has allowed Japanese companies to really be kind of forward looking and adopting edge.
Yeah, I think that, you know, from a timing perspective, they basically, by the time they were really understanding, and by the way, adopting and understanding the adoption curves and, you know, due diligence patterns are totally different.
Okay.
From the day that the cloud became, you know, part of our conscious, they were very, very aggressively studying this, as they typically do. And so but by the time they were ready to really start to take action, you had the emergence of the technology. They realized that this technology is not only, you don't have to go to a public cloud and pay public cloud a lot of money to do this. Most of the benefits that you can get in a public cloud, you can get in a private cloud.
So you think it really was more of a cost difference
It's not so much of a cost. You
than
mentioned
owning the hardware?
it's not okay. So there's a OpEx and CapEx
Yeah, okay.
question
Yeah.
here as well, right? You know, that's one of the appeals of the public cloud. It's much more of an OpEx play, where the CapEx, but again, understanding the CapEx and owning the CapEx is something that you would expect a Japanese company in this, as they're tapping this bridge, to really understand the cost. It's them that would realize, wow, if I do this in the cloud, it's going to cost me 4 times as much. If I'm willing to make this investment in our own data center, it's going to be a lot cheaper. They will do that. And they were doing that. And by the time, you know, they were ready to start really taking action in this whole new world, they had more options to them. And so I think that's a lot of the reason why you see, you know, these couple of examples that I gave,
Yeah.
as adoption of a private cloud to do what they had been thinking about that they would have to use the public cloud to do, if that
Okay.
makes sense. Actually,
Yeah.
sorry, go on.
No, go ahead.
Now there's I forgot. There's one more very interesting example I forgot, and this is the last page. But this is not only an example of a company that is probably be from the last industry that you would expect something like this to come out of, because it was the banking industry, which is the poster child for laggards here. But it's not only them taking an existing IT infrastructure and modernizing it. They were taking a 2,000-year-old practice and basically bringing it into the modern day. And this is MUFG, which is Japan's largest bank. And banks, as you may know, use something called the Hanko, which is the chop system. They don't, instead of signatures. And this system, their reliance on this system has been one of the major issues in their adoption of modern technology. So one step that they took last year, which is very interesting, is they worked with a couple of foreign providers of technology, including us, and they took 300 plus million Hankos and did high resolution scanning using AI, going in and being able to characterize the scans and match the chops in many different levels, is now allowing them, is getting rid of that impediment to adoption of other aspects of technology into their infrastructure.
Brian, I have to say, that's a great tease for our presentation next week, because our speaker is the Director of Digital Transformation for MUFG, who was directly involved in this project.
Oh, cool. Okay, very good.
So, yeah, thanks. It's fascinating. So 300 million stamps, right? I mean, you know, Hanko, it's kind of astounding. We got a couple of questions about IT talent, right? Personnel.
Yeah.
And I think the first question has to do with, you know, you mentioned early on in the talk that most people didn't really have that much IT talent inside the company. Right? They were mostly on the IT provider side.
Right.
And so now if they're moving into this and they're getting their own private clouds and so forth, isn't that more than a typical company's IT personnel would be able to manage? You know, wouldn't it be better to have something just sort of delivered to them like Amazon would deliver for a company?
Very, very good question. So there are a lot of moving parts here. One of them is the system integrator that I just described 10 years ago has moved on. I mean, they've truly, they realized they've seen the writing on the wall, and all system integrators are certainly the big ones have realized that they've done what they possibly could to understand the cloud. So they may be involved in some of these projects at some level. Another thing is that new system integrators, which are they call them born in the cloud, cloud native system integrators, have come up and become very important in this. So there are outside providers who can help. But at the same time, the companies that the groups that I'm talking about, they have worked very hard over the last number of years to develop that talent internally. And so the answer to your question is yes, it would be easier to just basically give it all to a public cloud, but for the same reasons that and again, some of this may be in a public cloud, but in these two examples, very little of it is. There are many Japanese companies.
Are you seeing a shift of kind of Japanese companies and more in their IT personnel recently?
I'm sorry, could you repeat the question?
Are you seeing a shift so that Japanese companies are investing more in their IT personnel?
Yeah, absolutely.
Is it a growth sector?
Exactly, and so the picture that I painted, 10, 20 years ago was one, it's more of a traditional one. And as I mentioned, these what they call these venture companies like Recruit and Amazon, Recruit and Rakuten and SoftBank, they've basically, shown the rest of industry what they need to, this is kind of the way to be successful, especially if you want to transform digitally. And so what you see in industry today is companies that large, even traditional companies are trying to hire or competing for the same talent, which they may not have even tried for years ago. And so, yeah, but one of the results of that is that the shortage of IT talent in Japan is expected to grow for the next, I think, 20 years. I haven't seen the latest statistics, but it is an incredible problem, and it's only getting worse every year, the shortage of IT talent. You see a lot of foreign talent for the first time. I mean, 20 years ago, you'd never see, I've been in some of you may be surprised to hear this. I've been in meetings with customers here in Japan where I'm meeting a Japanese customer, and there may be 8 people on the other table, on the other side of the table at the customer, and every single one of them are IT professionals, and every single one of them are not Japanese. That's an extreme situation, but it's something that happens today. So in some areas, and that's not a Toyota, or that's not a Mitsubishi, it's probably more like a Rakuten. In fact, that what I just described did happen at Rakuten with me. It gives you a flavor for some of the changes that are happening now in Japan.
Yeah. So conversely, there are an awful lot of IT personnel in Southeast Asia, in India, and so forth. And, okay, so some of them are moving to Japan, but do you see kind of those countries lagging in this really kind of movement toward edge, movement toward new types of cloud architecture?
Are you talking about other non-Japanese?
Other countries, like in Southeast Asia or in India, which have a large numbers of IT experts, but yet they don't, here are the Japanese who've had to import IT experts, and they're doing the advanced edge kind of computing stuff.
Yeah, so it's a very interesting question. I think that just from my perspective, what I see in those countries, so you may have you've had earlier cloud adoption, public cloud adoption in places like Singapore, maybe Hong Kong, and here and there. Certainly Australia, actually, and in the section on Asia, and what I believe was or important factors for choosing countries in Asia. As it turns out that in virtually all of these types of technology, and I'm talking about enterprise IT, the first adopters for all of these in virtually every case, next generation technology, is not Japan, it's not Hong Kong, it's not Singapore, it is Australia and New Zealand. And it has a lot to do with English language. But that being said, in these other countries, what you see is, in some cases, earlier cloud adoption. But what you don't see is some of these next generation use cases that I'm talking about here. Over time, I think you will see, and I've heard plans of doing this. You hear some of the smart city projects that are going on in a lot of these cities like Singapore have plans to do some of this, and some of them have implemented, some of them haven't, but it's all over the place. But I think it's the case of Japan is quite unique in how this has all played out over the last 10 years.
Kind of related to what's the slide that we're looking at now, the agricultural information example. Do you think that is this kind of Japanese strategy, government strategy, to really help build up digital capability in the country? So are they going to create these sort of shared data pools in maybe some industries? Because one of the problems with analytics, AI right now, is if you've got a huge amount of data, you arguably can do AI than if you don't have access to so much data. So do you think the government will come up with more shared data resources in other industries as well as agriculture?
Yeah, absolutely. And this is the perfect example of, as you say, especially when it comes to something like machine learning. It's not really going to get you anywhere unless you have not lots of data, but just huge amounts of data. And as everyone knows, things like voice recognition, the only reason it started to improve so much is that so many people started using it. And that's the data that they use to basically improve their accuracy. Very much in the same way, once they start interacting with the public, and the public actually starts providing feedback, the data sources can increase sometimes in orders of magnitude. And so they see that as a way to increase the data pools that they're going to feed into the training to improve the accuracy of their algorithms and their ability to create the actionable insights. And so this is something that is, yes, happening in agriculture, and you see similar projects happening in different places. We in America, we're doing this with a lot of U.S. government divisions, in some other countries as well. We work with 4 different groups, different government groups in Japan. Some of them with different varying levels of sophistication. This is the most sophisticated project that we're working in right now, and that's why I provided.
Okay. I've kind of way back early on, and the way I'd like to ask this question is, how do you spend your days at work? So you're trying to bring Cloudian into these projects. Do you work with local IT companies on the ground, or how do you get to a customer, and how do you, how do you do this? Because each one starts out in a different place. But do you find that most of your work is kind of working with existing Japanese, big IT firms, or is it going to the customers and then you find the IT firm to come in with some of the other resources that are necessary? Is it mostly on a large project scale?
Very interesting, and it's all over the place. But in general, when you're working with next generation, and this is something that I believe to be the best and probably the most effective way to introduce next generation technologies into Japan. And I'll limit this discussion to Japan. Until you have a product that is not quite commodity, but for which there is an existing and demonstrable demand for, it's very difficult to go to a large system integrator like a CTC or someone like that, and say Hitachi Solutions, and say, hey, please take my product and go promote it to your customers. It's just that they have to make an investment in every new product that they take on, and it's very difficult to do that. For me, my experience, and this has been, I've repeated this time and time again, is it's probably better to go out and one way or another, through relationships or through whatever way, through a user group, however it is that you can get the attention of the industries themselves, the enterprises themselves, to adopt your technology and create some what we call lighthouse customers. And once you have a lighthouse customer, especially if it is a major customer that a lot of people look up to for technology adoption, you have a much better chance, or much better opportunity to turn to a system integrator and say, look, we've done this, please take on our product. And that's where you really can start to see the scalability of your sales efforts. So that's the way I do it. That's how I kind of spend my day. Of course, by now, Cloudian has been in Japan for a number of years, and we do have existing relationships with resellers, but it's not easy to do that. And that whole play does often vary greatly in different geographies.
Well, and you know, in Japan, I'm often reminded that every sale is a new sale in
Right.
some way.
Sure.
So this has been great. One last question for you, and then we'll close off the formal part of the program. What do you see on the horizon? What's exciting for you? Where do you think we'll be talking about in 3 or 4 years?
It's a very good question. I think that you'll certainly see more and more companies, for all the reasons we've been talking about, you know, making major decisions to transform, and transforming often is not just making a series of small decisions, but very often you have to make, you know, one single very big decision to take a very big and very a significant step. And so I see more companies in Japan doing that. And you'll see, I think in the next year or so, you'll see a significant number of Japanese companies, even especially traditional companies, making that change. The venture companies I was talking about earlier, they've already made that decision and have long been going in that direction. As far as what is the next best thing, that's a very good question. I think you know, the distributed, I think you will see a continued motion out to the cloud for companies who have never done cloud, and realizing that, you know, they want a hybrid coming back. That's something that you've seen less of in Japan, because you have if their motion out to the cloud was delayed, their motion to repatriate will also be delayed. But you know, I think we'll see a lot of that, and that's exactly what has happened in the U.S. and Europe and places like that. But as far as what is the next greatest technology, that's a great question. I wish I had the answer to that.
Don't we all? But thanks very much for your perspectives, because that's a wonderful way to kind of bring us up to date and give us a different point of view. Up to this point in the series, we had really been talking to kind of people who are your customers, right, from different countries and so forth, about how their businesses are changing. And now talking about how the new technology is enabling the change is great, especially because this is a challenge, and it's great to see you doing good international business between Japan and the US. I want to thank everybody for coming today. We're going to continue in an informal optional session for anyone who can keep going. But Brian, thank you so much. Wonderful, wonderful presentation today.